A very good evening to one and all present here, guys. I welcome you all to the session. I believe every one of you is doing great and everything's been fine up here. Okay, so yeah, I welcome you all to this machine learning sessions. So, do we have someone like those who have attended my previous Python sessions? Yeah, or like everyone is complete? No, I can see some. Yes, I can see some names here, familiar names with Python. Those who were present with Python. Okay, okay, yeah. That's great to know that. Yeah, how are you guys doing? Every one of you. Great to see you guys here. That's really great to see you guys. Okay, so let's. Okay, and do we have anyone from here who have not attended my session? Like, do we have anyone from in the session here, those who have not attended my Python session and they have attended some other mentors session? Do we have someone like that? Anyone? Okay, hi Sai Prakash. Okay, Dhriti, what exactly the error you're getting? Okay. Anyway, so the reason why I was asking, like, if someone is basically coming from other mentors classes, the reason is because I wanted you guys to understand the basics of Pandas, Matplotlib, and NumPy. I believe you guys have gone through these libraries, right? So that is the reason why I was actually asking you. You should know how to load the data set and to perform some activities to train the data. Those activities, what actually we have already performed in our previous sessions. So that is the reason why I was asking that thing. It's okay. Yeah, okay. So no problem. If you see anything new, you can just ask me. I'll definitely let you know on that part. Okay. So let's just get started with our sessions here. So yeah, machine learning, right? Okay, just allow me for a minute, and then we can actually start with our machine learning sessions. Okay, just a minute. Dhriti, I cannot. I asked you to share the screenshot of what exactly you have given the input. I need to know that, right? So on the basis of that, I can tell you what exactly went wrong. Dhriti, do one thing. Just mail me your notebook file, and then I'll let you know what exactly you're doing wrong. Okay, I'll let you know there. Okay, fine. So let's just get started with our machine learning sessions. Okay, so yeah, machine learning, right? So before we start knowing about what exactly is machine learning, we need to understand. Dhriti, I just gave it to you just a while ago, just now. Did you get it? Yeah, it's okay, no problem. Anyway. Yeah. So as I was talking about this history of AI, so before we start with machine learning, we need to know what exactly is AI. Okay, what exactly is artificial intelligence? Okay, so AI was basically coined in the year 1956 by a computer scientist called John McCarthy. Okay, so they basically termed this word AI as science and engineering of making intelligent machines. So they basically made this machine intelligent, right, in some kind, okay, of its own kind. I mean, depending on that era, like intelligence on that era was different. Intelligence on in this era is actually a different concept. So that is what we have here. Okay, so yeah, in the College of Dartmouth, they were actually having a conference on computer science. So they basically just some of the people were standing around and they just coined this term called as artificial intelligence. Now, if you look at the evolutions and the future of machines, we actually started it from here, right? And in most of the cases, guys, whenever you hear this term AI, this is what comes to your mind, right? Whatever you're seeing on screens right now, this is what it comes to you, right? Whenever you are hearing this term called AI or machine learning or maybe deep learning. But in reality, guys, this is not everything. Like whenever you go, people basically show you these images of robots and all, and they call it as AI. No, AI is not only used in this humanoid robots. This is one area of application where we can add artificial intelligence in here. Okay, so that is not the definition of artificial intelligence. Artificial intelligence is not only like working as a human robot. No, it's not like that. You have several other aspects involved in your AI. Okay, so what exactly is this and all? We are going to look into it into much more details. And if you want to talk about this image, then I would say, yeah, we are basically somewhere in between this stage. Okay, like we have proceeded further with a normal humanoid to a humanoid with some prosthetics, right? So we are basically in this phase right now, and even after that, a few years, let's say 10 to 15 years, we might have the second phase, whatever we are, the last phase, whatever we are seeing on the screens right now. Okay, so I don't know when and how is it going to be possible. How I know, but I don't know when. Okay, actually, so let's just wait and let's just enjoy the future, enjoy the present, and let's be a part of the future here, right? So the first most important thing, guys. Okay, even before starting here, why AI is famous now. First of all, let me explain it to you guys. What exactly is AI? So let's just understand what exactly is AI, and then I shall get back to that point again. Okay. So over here, you basically see these two numbers, right? You basically have to multiply these two numbers. This is your first task, and the second task is to drive a car. So now, if I give you these two tasks, okay, like either to calculate this number, obviously without using calculator, and the second option to drive a car, which one are you going to choose? and why? Which one are you going to choose and why? Yes, people, I've got only a single response. Yes, yes, definitely. Exactly, like driving a car, right? So most of the people would basically say, yeah, driving a car is much more easier than calculating that above number, right? So actually, who is better at this? Yeah, guys, tell me, who is better at calculation? I mean, if you want to calculate this number, who are you going to ask to do this job? Obviously, calculator or basically a computer, right? You're going to ask a computer to do this task. That was the whole idea why we actually invented computer. Computer was actually invented to do the task where human beings are not good at it. For example, calculating this value, calculating this number, right? So humans were actually not good at calculating these numbers. So that is the reason why computers were actually launched, and computers were used to calculate this number in a much more better manner. Okay, so as of now, even before let's say 5 to 6 years, computers were looked upon as a subject which was actually designed to do the task which humans are not good at with. Okay, but now the definition is changing. What we are trying to do is, first of all, computers are doing the task which humans are not good at it. For example, this calculation. But along with that, now computer is trying to do the task where humans are already good at it. For example, driving. Like driving a car, humans are already better at this. But now we are teaching our computers to drive a car on its own. That is basically your AI or artificial intelligence. So if you basically put a definition of AI, then it's going to be like something like this. Like AI is basically giving the power to your computers to do the task which humans are already better at it. Like in short, in a nutshell, I can say the task mimicking a human behavior. AI is nothing about, it is basically about mimicking the human behavior. First of all, it is a computer, and the computer which mimics the human behavior. It's not only about driving the car, about everything what we humans do. Like we walk, we cook food, right? And we basically act in movies, right? We basically do some other stuff as well, right? So to mimic that human behavior is basically your AI. So AI, the whole game or the aim of AI is to mimic the human behavior, to be better at humans, even at the task which humans are already better now. Okay, if you compare driving a cars, so humans are already better at driving the cars rather than computers these days, right? Yeah, exception is Tesla and all, because the research is going on, and that too have happened only in this coming days. Like within this 1 or 2 years, we have seen that boost happening. Before that, yeah, it was nothing. Okay, they didn't have that much of technologies to support self-driving cars. Okay, but if you look into today's world, yeah, it's almost similar. So that is the whole aim of AI is. So to be better at things which humans are already good at it. That is the whole idea of AI. So fine, I'm talking about AI since a lot, right? But what connection does it have to do with machine learning? Okay, so until now I have used AI and ML interchangeably. Okay, but now we need to understand what exactly is AI. So let's say this complete umbrella is your AI. Okay, that is to drive a self car. Let's say we are making an autonomous cars. Okay, and that is the whole concept of AI. So within this AI, what do you have? You have some concepts of robotics. Okay, some concepts of data science, and then a pure concept of machine learning, and then a little bit concept of deep learning. That is AI. So do you understand now? AI is actually a complete picture, guys. But to achieve the goal of AI, we basically have to use some technology from ML, some technology from robotics, some technology from data science, some technologies even from deep learning to help achieve the goal of AI. Let's just say you want to make a self-driving car. Let's say you have to make an autonomous cars, but not the real cars on the roads, but let's say the playing car. Okay, let's say you have an area here and you want to drive a toy car, and you want to design that car without using machine learning. Let's say you want to take the approach of self-driving car. You want to achieve AI by using traditional programming. Let's say you want to use C++ or maybe Python. Okay, without machine learning. I'm talking about without machine learning. Okay, so basically, if you want to generate this algorithm by using C++ and Python, if you ask someone who is actually not that famous with AI, they would say it's impossible. But if you ask me, I would say it's possible. It's 100% possible to create an AI application by using C++ and Python. But as I told you, right, I just want to design a very basic application of AI which should take its own decision. So here in traditional programming, if you use this traditional programming approach, the file, whatever you will be writing, the code, whatever you will be writing, right, it will be a very lengthy code, guys. If you're writing a code by using C++ or Python without using machine learning concept, the code will be very lengthy and very huge, right? Even on the size, it will be it will consume a lot of memory, and there won't be proper optimizations. So that is the reason why to develop AI, we don't go for C++ or Python programming directly, but we rely on our machine learning models. Okay, we basically rely on machine learning models, and then we basically apply these machine learning models to the application what AI is actually working on. So AI and ML basically works with all together. Like there is no AI without ML, and with without AI, ML, where ML is going to get integrated. Okay, ML is applicable in most of the cases of AI applications. So that is the reason, guys, why we say AI and ML actually works parallelly, right? So that is the difference between AI and ML. AI is about taking some of its own decision. That is AI, like calculating its own decision, taking its own decision, mimicking a human behavior. That is AI. Now, the approach what we use to attain the goal of AI is basically either we have got two ways. Okay, to achieve the goals of AI, we have got two ways. One way is by using MLDL techniques. Okay, or the another approach is traditional programming like C++, C, Python, something like that. So just now I have explained you, right? So this is the approach what we are going to use. That is machine learning. We are not getting into deep learning, but yeah, we would get inside this machine learning. So we basically would take the concepts of machine learning, and then we shall proceed further. And one more thing, guys, in your C++ or traditional programming aspects, what happens is there is a degree of freedom. Like your model or your software cannot take a decision on its own. Okay, it is completely based on the basics of your conditions what you have provided, like if else condition, right? So on the basis of that, they basically take a decision. But here in machine learning, your machine basically have the ability to take its own decision. Okay, it's not like whatever the decision it will take, but we also test it. And at the end of the day, obviously, it is basically some mathematical calculation. Okay, but yeah, those mathematical calculation changes if you have a new data set approaching. Okay, so that also is a little bit different aspect from traditional programming concept. But yeah, you got to know, right? So that is what you have AI and then ML. Okay, so you need to understand that, guys. Okay, now coming back to this point, why AI is getting famous these days. So first of all, the most important part what you need to understand is you basically have more computational power these days. These days, if you look at your computers are really powerful, right? It basically have like really good computational power. The processors, the i5 8th gen, 10th gen processors what you're using is so heavy and it's so powerful. Okay, apart from that, even though if you don't have the latest computers, but you have the cloud technologies, for example, your Google Colab, right? The one what we have used, we basically got a very good CPU along with 13 GB RAM and 108 GB of hard disk, right? We got this thing. So how did we receive this thing? I mean, we didn't have this thing in our computer. We basically work on a cloud platform, right? So this is also one of the reasons why AI is getting famous these days, because you don't actually need to have a good configuration of laptop. If you even have a basic laptop, you can directly work with AI algorithms even on a basic laptop. So that is one of the most important thing what we have in the reasons why AI is getting famous. Then the second thing what you have is more data, all right? So these days, basically, you have really a lot data, and you can see here 2.5 quintillion bytes of data is generated every day. That is exabyte. So this is the data from 2020, guys, actually. So in 2020, there used to be 1 exabyte of data, which was actually generated every day. Okay, so that's a huge data, right, guys? Lots of amount of data you have there. Okay, exabytes, which is generated every day. So 1 exabyte, do you know how much is 1 exabyte? 1000 TB is actually 1 petabyte. 1000 terabyte is 1 petabyte, and then 1000 petabyte is 1 exabyte. So this is the data which is generated every day. So you basically have yeah, you basically have a lots of data, guys. Yeah, sorry about the sound, guys. Some 2 minutes work, not a big deal. Yeah, so more and more data, right? We basically have a really more data to basically process our algorithms. And then even the better algorithms, we basically have got a lot of good algorithms in computer science, which actually helped us to achieve our goals in a much more better manner. So improvement in computer science technologies also helped us a lot. And then last but not the least, the investments. So we basically have lots of investment. People are ready to invest a lot on AI technology. So if you're basically working on AI or ML, you can see the salaries. People are trying to give you really a good salaries, right? And not only about salaries, even if you're looking in getting some a startup, if you're trying to work in a startup, even in the startup, you basically get really good fundings if your project is somehow related to uh, AI. Okay, so that is the reason. Okay, so now let's just get forward and let's see what exactly is machine learning. Okay, to be specific, what exactly is machine learning? So just give me a moment. Okay, so as I was talking about what is machine learning, guys. So basically, there are two things in the world which actually do the job, right? One is basically us humans, and the second one is machines. The first is humans, and the second one is machines, basically, right? So how does a human basically learn to do its job? by the experience. Humans basically learn to do its job by some experience. But if you're talking about robots or maybe machines, it just follows instructions. That is the difference between a human and a machine, right? But now we have a new category of a machine which actually doesn't learn from experience, but it tries to mimic the human behavior. I told you, right? So human basically learn from experience, but this machine actually learns from data, like previous data. Okay. So for example, for a human being to get an experience, yeah, we need to have to attain certain age, right, to get that experience. Let's say if you want to be a really good at machine learning engineer, so you need to have at least 3 to 4 years of experience so that you can call yourself as a good machine learning engineer, because you will learn on the basis of some applications, some experiences. It takes time, right? But for your model, it's not going to take the time. If the model actually you already have a model ready, then it can be deployed within few minutes. Whichever the machine you want to give that experience, you can actually give the same experience within a matter of few minutes. And to train that, maybe it can take 1 or 2 days. That's it, maximum. Right? So to get your level of intelligence, guys, I'm not saying the exact level of intelligence, but giving a rough idea. So if you want to basically, like, you want to share your 20 years of experience, okay, whatever you have experienced in this 20 years, this machine can learn within, like, let's say 5 to 6 months. Okay, hardly. It will be even more than lesser than that, but I'm saying 5 to 6 months. Yeah, that is actually the danger part here. Okay. Anyway, so this is what actually it does. Okay. Now, if you talk about AI, yeah, one more thing actually I wanted to discuss here. Yeah, we are not going to discuss about these two concepts as of now. Just let's keep this thing out. I'll get back to this concept later on. Okay, so as of now, let's just leave this thing away. Okay, so let's just talk about this AI part. So whatever the AI technology you might be working on, right? You need to have a machine learning or a deep learning algorithm. What exactly do you mean by machine learning, deep learning, guys? Okay, well, how is it machine learning different from deep learning? See, if you want to basically work with some basic algorithms, you can go for machine learning. But if your algorithm is getting a little bit complex and you cannot basically predict the data by using machine learning, you're not getting that much of efficiency. Okay, your model is not that stable. Then what you can do is you can basically go for deep learning. So deep learning is actually a part of machine learning, but it's an extension of machine learning. It's an developed part of machine learning, we could say. It's a type of machine learning. So yeah, deep learning is actually one type of machine learning, but much more advanced than machine learning. Okay, now you guys must have seen of Alexa, right? You have seen Alexa, you have seen how exactly it works. Like you can basically talk to this Alexa and it basically replies to you in a much more better manner, right? So what exactly is happening in that Alexa? The main body or the constitution of that Alexa is this NLP, that is natural language processing. Okay, so that is one of the thing what you have in here, natural language processing. So this is what you basically have. Okay, but how do you achieve this? Yeah, how do you achieve this, guys? How do you achieve this? So there is a concept here, in computer science, which is called as natural language processing. Okay, the concept is to make our computers understand the language what we humans speak. Okay, that concept is called as natural language processing. But we can also use natural language processing by using our basic Python or basic C language. Okay, but when we try to integrate it with machine learning or deep learning, the results are mesmerizing. Okay, so that is actually your AI. Okay, so basically, guys, you have natural language processing here. If you want to make this now Alexa or something of that sort, you see, you can actually do that by using C++, just now, as I've told you, right? But apart from that, if you want to make it much more better, much more efficient, what you can do is you can just add it up with machine learning. So to work with NLP, see, whenever the data is like, what do we say, or the type of categories or numbers, we can use machine learning or deep learning. But the moment when you have the data in the form of voice or in the form of text, the English language, we cannot directly work with machine learning. So we need natural language processing to process that text data. Okay, and then we basically combined it with either machine learning or deep learning, depending on our requirement. If you need more efficiency, we go for deep learning. If you need a normal efficiency, we go for machine learning. That is how your AI module or AI system is actually built on. Okay, now let's say, what if your data is of images and videos? What if your data is of images and videos? Then what do? You basically apply this library called as OpenCV. Have you heard of this OpenCV? Computer vision library. That is image processing libraries. So you basically train your images with this, and then you basically again apply this computer vision either with machine learning or with deep learning to get your results. Okay, so you have seen the Tesla cars, right? Auto driving cars. So what is the main thing behind those cars? Your computer vision, your OpenCV. Even in your Tesla cars, they actually used to use OpenCV earlier. Now I'm not sure what exactly do they use, but yeah, initially they used to use OpenCV. Okay, to work with your images and to process the data or to train the algorithm, they used to use machine learning, but now they used to use this deep learning. Okay, even in this deep learning, there is something called as reinforcement learning, deep reinforcement learning. So this deep reinforcement learning is actually working with your computer vision. Okay, so before we proceed further, guys, okay, yeah, there's a movie something called as Ex Machina. Okay, I mean, it's an AI kind of a movie, but not that good. But yeah, it basically have a sentence in that which says AI is going to look back on us the same way we look on fossils. Okay, there's a character called Ethan who gives this dialogue, like, who is basically working on some AI modules. Okay, so it's like, yeah, this is one of the AI movies. But apart from that, guys, there is like in the mid of 20, I mean, deep learning. People were basically talking about AI and deep learning now. But do you know when exactly this change actually happened? when exactly this change actually happened? This happened in the year of 2016. Do you guys remember something out of it? Like what exactly happened in 2016 on the basis? I mean, I'm not talking about other concepts. I'm talking with respect to AI, deep learning, machine learning. Anyone? Can someone tell me? Okay, so have you guys heard of this game called Go? Yeah, have you heard of this game called Go? This is basically the Chinese, I mean, yeah, Eastern game basically, not the language. Go game. No, no, not that one. Okay. Yeah. So this is how your Go game looks like. Okay. So how you need to do is you basically have to like surround your opponent. Okay, you, let's say you might be white and your opponent might be black in pieces here. Okay, so basically now it says, you can see here, you basically have this black piece with you. So where do you want to keep it? Do you want to keep it here or do you want to keep it here? So if you basically keep it here, you basically get these 2 points from the opponent side. Okay, and these 2 points will be removed from the board basically. So this is something how your Go game works. Okay, so why am I talking about this Go game? Because see, to play, I mean, to play the chess game, uh, actually IBM came with a concept, okay, to defeat the world champions back then. Okay, I think Gary Kasparov was the name. IBM chess computer. If you search for IBM chess computer, then this is Deep Blue. Yeah, if you can see here, this is the match going on between the world champion Gary Kasparov at that time. Okay, see, this Gary Kasparov was actually the world champion of chess at that time, and here IBM was actually playing the game along with the world champion. Okay, obviously it was not playing on basis. The data was actually fed to the computer, and computer was actually uh, telling which steps they need to do. Okay, so basically the computer, the IBM supercomputer here, right? So this was the computer, the black color one, whatever you're seeing here, right? Yeah, this one. Deep Blue. It was basically called as Deep Blue. So this was the computer which was used to play against this Gary Kasparov, and yeah, somehow this IBM computer actually won a game of 3-0. Okay, there was a series of 3 games, and actually the computer actually won 3-0. Okay, so then like Gary Kasparov said, IBM have done some cheatings and all, something like that. But anyway, so this was the era in 1997. We're talking about 1997. But chess is actually easier comparatively with your Go game. If you compare your Go game, I mean, easier as in with respect to computer, right? Yeah, with respect to computer, it's basically easier. Why? Because here you have so much of moves to be taken place. If you can see here, 19 into, I don't know what these numbers are. Yeah, 19 into 19, so 19 square. So just imagine, guys, how many moves basically the computer has to know. If it was chess, in chess you just have 64 moves total. So combination, if you do a combination, you might get some specific amount of uh, like the moves what a computer has to learn. But if you talk about this game, it's almost impossible to do that by using the concept of chess what IBM have built. Okay, so for that reason you needed new technology. So there was a computer, I mean a company called as DeepMind. Okay, yeah, deep meaningful thoughts. Okay, no, I don't need those thoughts as of now. I'm fine with DeepMind technology. Yeah, so later Google actually acquired this DeepMind company. So they basically came up with an algorithm to defeat the I think 7 times or 11 times world champion. Okay, that was AlphaGo. They basically made this program who actually defeated this Lee Sedol. Okay, so he is basically South Korean, and he is current world champion even as of now, according to yeah, grandmaster. He's basically the grandmaster Lee Sedol, and you can see here there was a 5 game of series, and AlphaGo wins 4-1. So that is when people actually this news was basically broadcasted live. Okay, like completely live, and people were basically going crazy for this AlphaGo. Okay, so that was the stuff which was actually happening. There's a very good documentary on Google, guys. I mean on YouTube. It's also available on Netflix, but it's also available on YouTube. So you guys can just go through it. Okay, and it's a very good documentary to go watch actually. Okay. So AlphaGo, just search for AlphaGo, and it's actually a very good documentary. So that was the year in 2016 where everything got changed, and people started to understand the power of AI, like what exactly AI or deep learning networks can actually do. So I highly recommend you guys to please watch this movie, which is called as AlphaGo. Okay, so please watch this movie called as AlphaGo. I mean, you can do it on a weekend or something like that. And the another movie what I want you guys to go through is the social, not network, dilemma. Arre baba, why quotes? I don't need quotes. Yeah, so this is actually another movie which I really recommend you guys. It's available on Netflix. I'm not sure whether it's there on YouTube or not, but yeah, it's available on Netflix. So the social dilemma, it's an awesome movie, guys. You can just go through it and you would understand what exactly artificial intelligence is up to and what are the power of artificial intelligence. So highly recommendation, you can just go and watch these 2 movies. Okay, so yeah, that's what it is. Okay, so just go through it, guys. And that was the era, what I was telling, like this stuff is going to go above. Okay, so now if you actually look at the definition of machine learning, if you look at the what exactly Wikipedia says about machine learning, so you can see here Machine learning is basically the subfield of computer science that gives computers the ability to learn without being explicitly programmed. So there's an underline here, without being explicitly programmed. That is, computers basically would learn on its own. Like they basically don't have to being programmed to learn something. Like if there is a new concept what machine has to learn, you don't have to provide the program to make that thing. I mean, if you want to learn those things, right? You don't want to do that actually. Okay, so that is actually your machine learning. Okay, so and yeah, here guys, there is a conflict between like who coined the term machine learning. Okay, so IBM guys say there was like American scientist called Arthur Samuel who basically coined it for the first time in 1959. But in according to some other research papers, it says it was John McCarthy in 1956 who actually coined the term AI. But for machine learning, yeah, 1959, it is like yeah, for you can say machine learning was coined by Arthur Samuel, but AI was actually coined by that guy, John McCarthy. Okay. Now, let's get into the practical business of machine learning. So, where do you apply this machine learning? So, until now, whatever I have given you is all about the explanation of machine learning and how exactly machine learning works, right? But now we actually want to know how exactly do we work with this machine learning? Yeah. So, what is the practical approach of this machine learning? Okay. So, I'm going to give you a very basic example when we use our machine learning algorithm. Okay. So, let's say you basically have a 2 BHK home. You know the price of 2 BHK house. You know the price of 5 BHK house. Okay, you know that 2 BHK is going to cost you 70,000. You know 5 BHK is going to cost you 160,000. But what if you get something called as 3.5 BHK? What is the price of this house? Okay, you don't know what is the price of this house. You know what the price of 2 BHK, you know the price of 5 BHK, but you're not aware of the price of 3.5 BHK. So in this time, during this situation, how do you actually come up with this concept? How do you basically make a logic where we can actually guess the price of 3.5 BHK? Okay, so this approach can be solved by using a basic machine learning algorithm, the first machine learning algorithm what we are going to learn. Okay, so this is how it looks like. Like if you look into the price of the house, then on the x-axis we have the size of the house. Okay, these are the sizes comparatively, right? So 2 BHK, 3.5 BHK, and 5 BHK. So here we are going to have the price of the house. Okay, so there you go, guys. This is basically the size of the house. Okay, and then this is basically price of the house. This is size of the house. This is price of the house. And then here you have the data points. Okay, here you basically have a data points. Okay, uh, now guys, what are these data points? Basically these data points is actually coming from previous data sets. Like you must be having an information of about 1 BHK over here. This is for 2 BHK, this is for 3.5 BHK, this is for 3 BHK, this is for 4 BHK, this is for 4.25 BHK, and this is for 5 BHK, something like that, right? So these are the previous data sets what you have. So by taking the consideration of all these points, we basically want to find out the point which where we don't have the data. Like we don't have a data for 3.5 BHK, right? So what exactly do we do here? So to solve this problem, according to machine learning, what we do is we basically draw a best fit line over here, a straight line in such a way that this line basically is very close to all these data points. Like it's not possible to match all those points, right? Because this is not in exactly in the same line. But our main aim goal is to pass this line through in such a way that the points are very near. All the points are nearer to this point, and this line is basically called as best fit line. Okay, there are approaches of finding this best fit line, which we are definitely going to look into much more detailed manner. But as of now, let me just explain it to you guys how exactly it works, right? So the price of this home was how much? $70,000, right? This was already available, like $70,000. Yeah, this is in $10,000. So 7 months, $70,000, and this one you also had this one, which was how much? 170. Yeah, $170,000. So 17 basically, 15, 17. Okay. Now, according to this best fit line, whatever we have drawn, what we will do is we will basically draw a perpendicular line in above with this, and then with respect to this line, whatever we have received, we would basically match this up. Okay. Yeah, the line is not correct here. Okay, but this is how it's going to look like. Like on the x-axis, we are going to check what is the y-coordinate of this line. So that is 12. So according to our machine learning algorithm, we got to know that a price of 3.5 BHK is $120,000. Yeah, 120. Yeah, 120,000. Yes, thank you. Okay, yeah, thank you. Actually, some internet issue here, so that is the reason. Let me just change it to my network. My network is back. Let me just change. Okay. Yeah. Okay. So you can see here, guys. Basically, yeah. So according to this best fit line, we basically worked with this 3.5 years of experience. We got 120,000 over here. Okay. So similarly, if you proceed further, okay. So this is what I mean. They have drawn it for us, and exactly the same thing, right? So do you remember, guys, where exactly you worked with this stuff? Like, where exactly did you work with this? Yeah, the slope thing. Where have you worked with this? I believe, yes, you basically have used this for your chemistry experiments, I believe, for your titration and all to find out some specific value, right? Or to find, even in physics, to find specific values, you basically used to plot x and y axis, draw a best fit line, and then you basically was finding out that. So yeah, that is what you have studied in your basic classes. And today, one of your machine learning algorithm is based on this concept. Yes, exactly. Y is equal to mx plus c, right? And this concept is called as linear regression. So that is how, and that is what your linear regression looks like and works like. Okay. So yeah, this is actually a very basic concept in machine learning, guys. That is basically your linear regression. Okay, understood, guys? Yeah, this is what uh, is linear regression. Okay. Man, regression is applying, like, after another time, and first checking out with some value. That it's kind of iteration, okay, but not completely iterations. But yeah, you will get to know when I actually explain you about what exactly happens here. You would understand that. Okay, so that is basically called as regression here. Okay, so let's proceed further and let's just see what exactly do we have in here. Okay. Okay, so let's just proceed further. And yeah, the differences, like here you basically have the differences between like what is AI, what is ML, and what is deep learning. I've already explained you guys regarding this, right? So yeah, let's just let's just proceed further, and then you can see here, guys. So these are your older machine learning algorithms, like your machine learning algorithms. Here you can see up to a specific point, if you're giving an amount of data, the performance is increased. But if your amount of data basically increases, then what happens? Then in your machine learning algorithm, the performance is exactly the same. There is no difference in the performance. But in deep learning algorithms, the performance also increases by time. Okay, I mean, not by time, but by amount of data. So if you really have huge amount of data, it's basically like, it's considered better to try with deep learning algorithms. Okay, so that is what you can actually try it out. Okay, so this was about linear regression. Okay, now let's look at some other machine learning algorithm, what we used to see. Basically, guys, here it says acceptance at a university. We need to find out whether the student will basically get an admission or not. Okay, so that's what we need to check it out. So this is what the data you have. Student 1 basically scores 9 out of 10. Student 2 scores 3 out of 10 in test, and 8 out of 10 in grades, 4 out of 10 in grades for student 2. This is the data what you have. So student 1 basically gets an admission, but student 2 doesn't. Similarly, you have a student 3 data who basically have test score 7 by 10 and grade 6 by 10. So what do you guys think? Is this person going to get an admission? What is it? So we need to figure this thing out by using our ML algorithm. We have to use our ML algorithm for this. Okay. So how do we do this? Let's understand and let's proceed further. Okay. So let's say this is what the students mark we have here. Student 3 is here. Student 1 is here. Okay. How about student 3? I mean, we cannot draw a classification line here, right? I mean, a regression line. We cannot draw a regression line and we can say, yeah, everything on this line, we can work with it. No, it's basically simply not possible. So what we do is we basically take some more data sets Okay, this is basically the previous data sets what we have from the university for whom they have given the admissions, historical data set basically. Okay, so depending on this data set, now we can see the green areas are for the people, those who have received the admission, those who were successful in getting the admission, and this area is for the people, those who didn't receive the admission, basically, right? So now to categorize this data, like, are we able to draw a linear regression line here? Is it possible? No, we need another approach here to do this. That approach is nothing but we would classify this line like this. Yeah, we would basically classify the line like this. Okay, I mean, it will be a straight line. Obviously, I have drawn it in this way, but in reality, this is going to be a straight line. So you classify the data. So how do you classify the data here? Anything that comes on the right hand side basically gets an admission. Okay, and anything which comes on the left hand side basically doesn't get the admission. Okay, so if that is the case, guys, if you can see, yeah, this is the line what we have, student 3. So let us place student 3 here. What is the test score? Yeah, this is test and this is grades. Yeah, so test score is 7. Again, what is the grade score? Grade score is 6. So basically our point is somewhere around here. So what does it say? It says, yeah, we are basically going to get an admission. If basically this is the marks, then we are definitely going to get an admission. Okay, so guys, there were some changes in two, I mean, algorithms. See, this algorithm is basically called as logistic regression. Okay, this algorithm is basically called as logistic regression, the one what we have seen just now. Now guys, my question for you guys is, what exactly was the difference between the previous algorithm and this algorithm? What is the difference between the previous algorithm and this algorithm? So can you guys tell me what exactly was the difference? Yes, Harshit, exactly. Okay. No, let's just look into the linear regression again. Okay, so in this linear regression, guys, basically, what were we expecting? Yeah, your y value, right? Y value is, let's say this is x value and this is y, x and y axis. So what were our y value? What can be our y value in this case of linear regression? Do you have a certain range of y value? Do you have a specific class for your y value? No, you don't. Yeah, you might have a range basically, but you don't know what your answer is going to be. Your answer is going to be in a continuous form. Like the value can be $120,000, the value can be $121,000, the value can be $119,456,000, anything. The value is continuous in nature here. Do you understand, guys? The value here is continuous in nature. It can be any value, right? There is no specific range. Like agar ye hai to ye hai, varna ye hai. Nothing like that. It's continuous in nature. And then, in case of this, what do you have here? Here, what is your output? What is your y? The output. Y as in the output. What is the y here? What are we trying to find here? Exactly. We just find either yes or no. These are the only two things what we are trying to find out here. The end goal is whether we are going to get an admission or not. So these kind of algorithms which we work on is called as classification algorithm. This kind of algorithm is called as classification algorithm, where your output can be of any of the classes, and it's not mandatory that you need to have two classes. The classes can be of any types. Okay, it can be of 4 types, A, B, C, D. Like let's say here we have 2 classes, like yes and no. But similarly, in previous, I mean, in further examples, you might see 4 different classes. So if we are expecting Y as an output. If our Y is any one of this A, B, C, D, then we can say this algorithm is classification, right? Because we already know the classes. The output can be any one out of these 4. That is called as classification. But if you look at this, you are not aware of what value it can be. It can be 120, it can be 190, it can be anything. There is no specific class here we are trying to detect. We are trying to detect the continuous value. That is the difference between regression and classification. Understood, guys? The difference between regression and classification? Okay. So let me give you an example. Okay. How about weather forecasting? Like I want to understand tomorrow at the same time, what is the weather going to be at my place? What is the temperature going to be at my place? I want to understand that. What is my temperature level? What is my humidity level tomorrow at the same time? So what example is this? Is this classification or is this a regression? What one is this? Or which one is this, to be specific? Yes, this is actually a part of regression, because see, tomorrow the value can be anything. It can be 29.1, 29.2, okay, or maybe 32.5 or maybe 35.6, anything, right? So this is basically a regression. But what if my question was, if I want to find out tomorrow at the same time, is it going to rain or not? Then what kind of a problem is this? Yes, exactly. Then it is basically a kind of classification problem. Like whether the rain is going to happen or not, it's basically a classification. But what temperature is it going to be tomorrow? That is basically a regression. Okay, I'll explain again. Just a minute. Give me. Okay, so let me explain you this. Okay, how it was classification, because I just asked whether it is going to rain or it's not going to rain, right? So here it was only of two classes, either yes or no, right? Or you can say 1 or 0, that's it. Or even if you have, you can have until 0, 1, 2, 3, let's say 4 classes. Then you might have 0, 1, 2, 3, 4 different classes. That's all you need to have. Okay, that's all you need to have, either yes or no, or maybe like 4 different conditions. But if I'm talking about temperature, do you know what the temperature can be? Yeah, you might know the range. You can say it can be in between 22 or 35. But do you know exactly what is it going to be? No. Okay, we cannot say 20.1, 20.2. We cannot say that, right? So that is the reason. Yeah, that is the reason why this temperature would be actually a linear regression. And to find out whether rain or not rain is actually a classification. Okay, that is the reason why you have a classification and a regression actually. Okay, fine. Okay, now one more thing, guys. What I wanted to tell you here is there is a concept of dependent variable and independent variable. So what exactly is that? So this is basically size of the house, right? So what exactly is the size of the house? So here, guys, this is size of the house and this is price of the house. So you guys tell me which one is a dependent variable here? Which one is the dependent variable? Or which one is the independent variable? Okay, dependent variable, I think it is dependent on some factor, right? So you guys tell me which is independent. First of all, you tell me which is independent. Like it's not dependent on any of the factor. Yes, the size of the house. The size of the house is independent because it can be anything. It can be 3, it can be 3.5, it can be 4. No one is there to control that size, right? So size is independent. But if you talk about price, it's completely dependent on size. As the size increases, the price also increases. So price of the house is completely dependent on your size of the house. So your independent variable is basically called as features. In machine learning lingo, your uh, like independent variables are called as features, and the dependent variables are called as labels. Okay, these are called as features and these are called as labels, the output basically. So these features are also called as input variable and labels are also called as output variable. So you need to understand that from now on, whenever I'm talking about x and y, x is basically a feature or an independent variable, and y is basically the dependent variable or label or output. So these are the 3 different names what you guys need to remember. So I can use any one of the names. Okay, either I can use feature labels, I can use dependent independent, I can use x, y, or I can also use input output. So you guys need to understand this in a much more better manner. Okay, guys. So yeah, independent and dependent. Okay, x and y, input output, and then feature label. Yeah, this is how it looks like. Okay, so I can use any one of these. So if I'm using feature, I would call it as label. If I'm using input, this is output, this is x, this is y. Okay, so something like that. This is how it looks like. Okay, so now you know what is dependent and independent variable. You tell me here in this problem statement which one is dependent variable, which one is independent variable, or which one is x and which one is y. Tell me, please tell me. Figure it out and tell me which one is what. Okay, where is my pointer? Acha. Okay, so I've got some responses here. Let's look into here. Okay, X is grade, Y is decision. Okay, grades are dependent on test. Okay, test is X and grade is Y. I mean, okay, I didn't get this. Okay, so here guys, you need to understand that your test and grades, right? Your test and grades, basically, your test and grades, both are independent. It is not dependent on any of the factor. So these are your inputs, X1, X2. Yeah, you are plotting it on the Y-axis, but in this expression, I'm giving it the name as X2. Then what is Y on your label? Your label is the admission, whether you're getting an admission or not, yes or no. The admission, whether you're getting an admission or not, is basically the label. And here, these are independent. Your test and grades are basically independent variables. Okay, so that's what you have in here. Okay, so that is X1 and X2. Okay, now one of the confusion you might have. Okay, one of the confusion what you might have is I told that this is basically a classification algorithm. Then why does it say even logistic regression now? I mean, I've already informed you guys that this is basically a logistic regression, but I also told you that this is a classification problem. So why the name regression? If it is a classification problem, why the name is regression? You will get your answers very soon the moment when we start working with logistic regression. Okay, then you would understand why the name is logistic regression, even though if it is a classification problem. Okay, so let's proceed further. Okay, you don't have to know, see here. Applications, yeah, you already know what are the applications of ML, like recommendation engines, okay, and cure leukemia, Amazon recommendation system, Facebook face verification, auto tagging, and then by self-driving cars using deep learning, okay, and then machine learning everywhere, like voice assistants, drug discovery, AlphaGo, just now what we saw, right, AlphaGo, then like cancer diagnosis, face detection, assisted driving, so much of stuff we have. And then, yeah, we are going to use Python here, obviously. Okay, there are R language also available, but in most of the cases, we basically prefer Python. Okay, so we will be working with Python. Yeah, you don't need to know all of these. Okay, so let's just get started from here. Okay, so this basically explains us like what exactly is the difference between a traditional programming approach and a machine learning approach. Like what exactly is the difference? Okay, so in the traditional programming approach, what do you have is you basically give the data here as an input. Okay, and you basically give the program. Let's say the program is of a plus b. The program is a plus b, and you're giving a data like 2,3. Okay, you're giving a data like 2,3. Okay, then what is the output you get? You have a program a plus b. The value is given here, a is equal to 2, b is equal to 3. The output what you receive is 5. Okay, so this is how traditional programming works. But in machine learning, what happens? You basically say that I'm giving a data as 2,3 and the output is 5. Yeah, you basically give the input as 2,3 and the output as 5, and not only one program, you basically give 100 different iterations. This is first iteration what you are seeing, right? Similarly, you give 100 different iterations. So let's just talk about first iteration itself. So you're giving a data 2,3 and the output is also 5. So your machine would actually make its own model. It will check, okay, what operation do I need to do so that I can take this input 2 and 3 and make the output as 5. So what operation do I have to choose here? That is the model. That is what you understand by model. So model would say, yes, you need to do an addition here. So if you do an addition, you are going to get the same output. So this is a very simple example what I've shown it to you guys, but this is the whole idea. Okay, this is the whole logic behind your machine learning algorithms. Like you basically have the data, you basically pass the data, and then you basically give the output, and according to your output, you basically make your model ready. Okay, so that is what it does. It basically learns from the data, like whatever the data you have. So here I just have 2 and 3. Okay, in the second iteration, I might give 7 and 4. I might give 11. Excuse me, guys. Yeah, 7 and 4, 11. And in the some more iteration, I would have 6, 3, and the output is 9. Excuse me. And then 3 and 4, the output is 7. So these are the data what I'm going to pass, and I'm going to give the output as well. So our algorithm will check applying plus in every condition. And if everything matches, then we say the operation is plus, we need to use, and the accuracy is 100%. Instead of 100%, what if we had 7.3 as the data or 9.2 as the data? Okay, so at that time we can say that accuracy can be around 98% or something like that. Okay. So this is how our machine learning model actually works. Understood, guys? This is how it works. Okay. Now talking about a process involved in machine learning models, guys. So let's say I'll divide it into two parts. This is A part and this is B part. The remaining one is B. This is A. Let's say you're working on a machine learning project. You have 5 to 6 months of time to complete the project. Do you know how much time are you going to spend in this area? At least 3 to 4 months. Yeah, at least 3 to 4 months, you would basically spend your time in this area. Like first of all, collecting the data, then basically discovering the data, then basically structuring the data, then cleaning the data, wrangling the data, mining the data. All those you need to do here. And then when everything is done, you basically have to visualize the data. We have to analyze the data. You have to understand that what can be the output. What is the scope of output? How are we going to cope up with this? So all this information you need to understand here in this part A, and which is going to take almost 4 to 5 months, I would say, or 3 to 4 months is minimum. Okay, and remaining 1 to 2 months you would basically spend over here, like to make an ML algorithm, okay, to train the algorithm, to test it, whether it's working correctly or not. You want to test it, and finally you will basically deploy it in a real environment. Okay, so that is what actually we need to do. Okay, that is what we have already covered this part. Okay, like we didn't collect the data. I actually gave the data which was already collected. You actually cleaned some of the data basically. Okay, and then you visualize the data, you analyze the data. So we are done with this part. Now we basically want to focus on part B. Part A is already done. We would be focusing on part B from now on. Right, that is the whole aim of machine learning classes. Okay, so inside the machine learning, now there are 3 different types of algorithms. Okay, 3 different types of algorithms: supervised, unsupervised, reinforcement. So what exactly do you mean by supervised algorithm? Okay, let's take an example of this. This is an images of Apple. Okay, guys, these are the images of Apple. So that is your training data set. Okay, these are the images of Apple you have, and this is your training data set. And along with these images of Apple, you also have desired output that is called as Apple. Like this is the data set what you have, and for every image of an apple, you are mentioning that this is Apple. Okay, this is Apple. Like you're mentioning, like for every input, you are mentioning that this is Apple, this is Apple, this is Apple. So if you have 100 images of Apple, you are mentioning Apple for hundreds of times. Okay, you are mentioning that, yeah, this is Apple, this is Apple, this is Apple. Now what happens? Now you basically give the input of Apple. Okay, you basically give the input of new Apple, which is not a form of this Apple, a different Apple, a kind of a little bit different Apple. Then your model basically will predict that it's an Apple. And if this thing happens, then we can say that we have successfully built our machine learning model, and this is called as supervised learning. Why does it say supervised learning? Because you do have a supervisor here. Like there is a supervised learning, you know what is the output there. Okay, so depending on the output, the algorithm is designed. So this kind of learning is called as supervised learning. Understood, guys? You are giving the inputs and you are also giving the output. So that is your supervised learning. Okay, now in the next attempt, what do you have here? In unsupervised learning, you just take a bunch of fruits. Okay, you don't know what fruits do you have. You just take images of all the fruits and then you basically pass the data. Okay, here you're not mentioning that this is apple, this is banana, nothing. You're just giving the images of apple, banana, and mangoes. What your algorithm actually do here is it first looks at this piece. Okay, it understands the feature of this apple. Now what happens? Again, the second apple comes in. So what happens? This apple and this apple basically have similar feature. So they basically group each other. They basically, like, call themselves as they are inside one group. So similarly, this also groups one together. Mango also groups into one another. This is how it works. Like apple finds its own group, banana forms its own group, mango forms its own group. So here the output will be the list of apples basically from one group. It will say this is from class 1, this is from class 2, this is from class 3. This is unsupervised learning. Understood, guys? Have you understood, or is it there a confusion there? See, in the previous attempt here also, guys, it's not mandatory that you have to give apple alone. No, you can also give banana. Yeah, that's a very weird looking banana, I know. Okay, here also you can give banana and you can give the name that this is banana. Okay, or if you have oranges, you can give oranges also, but you have to mention that these are oranges. This is what happens in supervised learning. But in unsupervised learning, you're not mentioning that this is apple, this is banana, nothing. You just give a bunch of data and your algorithm basically decides that, yeah, this is apple, this is mango, sorry, this is banana, this is mango. I mean, it doesn't say apple, banana, mango, but it will say 1, 2, and 3 because model doesn't know that this is apple or this is banana. They have just featured themselves in one place because it used to look same. That is the reason why they have given in the same group. Okay, so now you must be wondering what is the advantage of this. Yeah, the advantage is, guys, here we know that these are apples, these are from same class. But what if you have a data where we cannot visualize it? We cannot understand whether which class is this from. So at that time, we can basically use this kind of algorithm. And actually, this is called as clustering. This algorithm is actually called as clustering, whatever we have done here. Yes, Vamshi, that's what I was talking about, right? So the algorithm what I've shown you right now is actually an example of unsupervised learning. And to be precise, this example is called as clustering. No, Nayan, why? Why do you want to do it supervised it? Just give the data, like collect the photos of these images, give the data directly. You don't have to do anything. Just take the inputs, give the data. You don't have to mention this is apple, this is banana. Nothing. Understood? Yeah. Based on the similar features. Based on the similar features, Nayan. For example, let's say we are working on apple. Let's say if we are working on apple, it will say, okay, the first feature is it is red. The second feature is it has a diameter of 5 centimeters. Let's just say, okay, the skin is basically hard. So it will basically look for any other fruit or any other object which is of red color, which has a diameter of 5 centimeter and which is hard in nature. If you get these properties along with them, then it will say, yeah, this is basically of the similar feature. Yes, exactly, Silohit. Oh, thank you so much for making me understand. I mean, making me remember this. In your Google Photos, guys, it basically says, right, similar faces. It basically clubs your similar faces, even though your Android doesn't know whether who is this person, but it will basically say, yeah, this is basically similar feature or similar faces, right? So that is called as clustering. In unsupervised learning, the idea is you don't have the output, you have just an input, and with input, you basically go further with different types of algorithms. Okay, so here you have clustering, but there is again something called as association. Okay, and then there is again called as dimension reduction. Okay, so these are the different types of unsupervised learning. We'll go through all of this later. Okay, but as of now, you understand this part. Okay, so now you guys tell me, what learning did we do in our housing price? Like we were predicting the house prices, right? So what was that? Was it unsupervised or supervised learning? Yeah, was it supervised or unsupervised, guys? Yes, that was completely supervised. Why? You already knew what was the prices of the other houses in the same area. You just didn't know what is the price of this specific house. But while training the algorithm, you actually knew what are the prices of the other houses in that area, right? So that was supervised learning. And what about the admission example? Admission example. Was it unsupervised, unsupervised? Was it unsupervised or supervised? Guys, it was again a supervised model. Okay, because how did you get to know these points? The points what we have given there, which I have shown you. Yeah, these green points. How did you get to know that these are green points and these are red points? How did you get to know? These are not black points. These are green points. These are red points. So your algorithm already knew. Like this, the points on the right hand side is actually green. The points on the left hand side is red actually. Okay, that is the reason here we call it as supervised learning, right, guys? Here, yeah, I know. In this y-axis, you actually had feature here, right? But your output is lying over here in form of color, like green color and red color. This is actually the output here. Understood, guys? So both the examples, whatever we have seen, is actually a type of supervised learning. Okay, so supervised, unsupervised is done. Okay, yeah, this is what I said, right? Unsupervised clustering example. I gave an example of clustering, right? So this is how clustering basically looks like. You just give the data and it will understand, or it will make its own class of data depending on the inputs, whatever you have. Okay, now if you talk about various algorithms in supervised learning, okay, if you look into supervised learning, it's divided into two classes, whether regression or classification. Okay, if you're talking about supervised learning, it will be either a regression or a classification. In regression, we are going to see linear regression, then simple linear regression, multiple linear regression. Okay, and then if you talk about classification, we have logistic regression, which I have already explained to you. Then you have decision trees, you have random forest, you have KNN. Okay, and then you also have SVM here, and then you also have naive Bayes here. Okay, so these are the type of algorithms what we are going to build. Yeah, Dhriti, it would be better if you take notes. Okay. Yeah, so 1, 2, 3, 4, 5, 6, 7, and finally in unsupervised learning, we are going to do this k-means clustering. Okay, so total of 8 to 9 algorithms we are going to learn in this machine learning duration, guys. Whatever the machine learning duration we have, right? So we are going to study about 8 to 9 different clustering examples. Okay, sorry, not clustering, machine learning examples, machine learning models. Yeah, we are going to look at 8 to 9 different machine learning models. Okay. So our concentration is more on supervised learning, and under supervised learning, we are concentrating more on classification, because in real world, most of the data, or most of the problems what we solve is classification problem. But yeah, you also see k-means and linear regression over here, where we basically predict uh, different types of output. We basically predict different types of output, right? Yeah, so we are going to do that as well. Okay, then what about reinforcement learning? Reinforcement learning is nothing but, yeah, in reinforcement learning is basically training a kid. Okay, let's say you have a kid at your home, your siblings or someone, or your cousin maybe, or even ourselves. Like just imagine how we were being brought up. Okay, like in this environment, like Indian parents, like Desi parents, what they do, they basically ask you to go for an exam. Okay, you basically go and you write an exam. Now, if you get good marks in your exam, okay, if you get good marks in your exam, what happens? You basically get rewards, right? Rewards as a form of some games or something like that, right? But if you basically do bad in your exams, then what do you get? You get punishment, you get penalties, right? In the form of, yeah, mama ki chappal, papa belt, right? Anything else? Yeah, maybe a spatula, or yeah, we know varieties. I know there is no need to be ashamed, guys. I know everyone have gone through this. Okay, so yeah, you basically understand here, right? If you're getting good in the exam, so basically kids understand in this fashion, like if we are scoring good marks, we are getting rewards. So we basically have to do good every time in the examination. This is what we have been trained into. This is how we have trained. This is how our mind is trained. Similarly, the same thing we do with our model. Okay, this is our model. Our agent is nothing but our model. Okay, so depending on the environment, we basically take an action. Okay, so you take an action depending on the environment. Let's say self-driving car. If you're driving a car, let's say this is a dead end and this is your car. Your car is moving in the forward direction. What if it doesn't take a left or a right? It hits the wall. Then what's going to happen is you're going to give a penalty. Now, for the next time, if you run the car here in the same track, your car would understand that if I hit this wall, I'm again going to get penalty. So this time it will either take a left turn or a right turn to avoid penalties. And if it takes a right turn, then it will basically get some rewards. Then for the next time, whenever the model basically sees a wall, it will take a right turn because he know that if it's taking a right turn, he's basically getting rewarded back. Right? So this is how your reinforcement learning basically works. Okay. So now, yeah, if you look into this, guys, this is how your different types of learning looks like. Like in your unsupervised learning, sorry, in supervised learning, you have regression, classification, like forecasting data, sales, okay, predictions, and then in classification, diagnostics. Whether let's say you are going to have a cancer or not, depending on some features, we can find this thing out. That is diagnostics, right? And then customer retention, if you want to retain the customers, or fraud detection, whether this person is going to do a fraud or not. So we can understand that by using our machine learning algorithms, right? So this is what we can do. And under unsupervised learning, I've told you, right? We have clustering first of all, and then you have dimension reductions, and then association. Yeah, this recommended system is basically a part of association. Anyway, I'll talk about these stuffs later. And if you talk about reinforcement learning is a type of learning where we take real-time decisions, where you actually want to take real-time decisions and your algorithm basically learns on its own. You're not giving any prior data. It basically tries to learn on its own, like your robo navigation and even in your self-driving cars, right? Your Tesla cars, whatever you see. What is that? That is nothing but deep reinforcement learning. It tries to automate the car. It tries to drive the car with its own experience, basically. I mean, they didn't basically leave the car directly in the environment. They basically designed a simulator. They designed it on a simulator and then they practice it on the real world mechanism. Okay. Yeah, then these are the different steps involved in machine learning algorithms. Yeah, you can basically go through the steps and you can basically figure it out how to work it. I mean, I'll let you know, guys. You don't have to worry about the steps if you're not understanding any of this. It's completely fine. I'm going to explain you, walk through this, all of these stuffs. Then use machine learning to predict whether you're having a cancer or not, something like that. Whether is it a benign tumor or is it a malignant tumor, right? So these are the data set, guys. What you have. Okay, this is from the previous patients. So these are the data sets from your previous patients. So you make a model based out of previous patients, and then this is your data. Sorry, not your, any one of the patient's data. So with this data, you get this features. So all of these are features, like from X1 until Xn. All of these are features. Yeah, features can be anything, guys. There is no limit to the number of features. In some of the real world data, I have even heard people saying they have used thousands of features, lakhs of features. Okay, so there is no limitation of features, guys. Okay, anyway, so these are the features. Now we need to predict whether this tumor is of benign type or malignant type. Benign is basically the beginner type, malignant is actually the serious type, right? So by giving the data, we got to know that, yeah, this is basically of benign type. And yeah, it's not much to worry about. Okay. Yes, features are independent. Exactly. It's not dependent. It shouldn't be dependent on any other factor. If it is completely dependent on the factor, I mean, any one of the input, then you cannot call it as a feature. You basically have to remove that. Okay. I mean, if you're having and if you're looking at some other output, otherwise make that feature as the output. Okay. So something like that, guys. So this is what we have done today. Okay. So this was a very rough or a very simple introduction of machine learning. And what exactly is machine learning? What are the types of machine learning? Okay, how to achieve the goals of machine learning. So that is what we have studied today. Okay, so now, guys, you tell me, yeah, if you have any doubts or any concerns, you can basically ask me. See, I'm not going for the next topic because if I start the next topic, I minimum to minimum require half an hour, and we don't have that much of time. So, yeah, I'll share the drive link. No problem. I'll share the drive link tomorrow when we'll be working with it, right? So I'll share it. And yeah, PPT. Okay, I'll share that. Don't worry. Okay. Not now, but I'll share it. Okay. Okay, Sumaya, we'll do one thing. I'll explain you. Like we do have, yeah, you basically have to give a different data frame, Sumaya, to work with this. You basically have to give different data frames. I mean, acha, like this one you're talking about. Okay. I'll share this image. I mean, I'll share the solution for that. Don't worry. Okay, within 1 or 2 days, I'll actually share the solution. You can go through it. And regarding the drive link, yeah, I'll share it tomorrow when we are working with the data set, right? We'll do it tomorrow. Okay. Raj Vagankar. Yeah, C++, I mean, as of now, we are not going to use the C++ or Java. Okay, but yeah, it will help you in a longer run, definitely. But here we are just going to model it, right? So C++ and Java will be used when you're trying to integrate these machine learning models into some of the application. At that time, definitely it's going to help you. Oh, you're learning Q learning. Okay, Amit. Part of deep learning, actually. I mean, deep reinforcement learning, Q learning, right? Okay, we'll look into that, Amit. Okay. You will get, today is the first day, guys. So let us complete 2 weeks at least, and then you will get your minor project. Okay. No, Nirmal, it's actually not allowed. Okay, that is the reason why we don't do that. But we do have a Google Drive link, right? So I'll give you there. Okay. Fine then, guys. I believe you have understood, right? What exactly is machine learning? Yes, guys. Have you understood the overall concept of machine learning? Is it confusing? Is it like related, or how is it? Understood, right? Okay, great to know that. Thank you so much. Yes, Ronak, we'll start our practicals from tomorrow. Okay. No assignments for today. Okay, we'll start with tomorrow. Okay, no problem there. Fine then, guys. Thank you so much. If you have any doubts, you can ask me. Otherwise, you can leave. Okay. If you have any issues or concerns, you can ask. Otherwise, you may leave. Yes, guys, you can leave the class. And regarding the projects, I told you, right, you will get it within, let's say, 1 or 2 weeks. Okay, because just now we have started with the sessions. So give us 2 weeks, 1 or 2 weeks of time, and then you guys have to learn something, right, before you do a project. So don't worry, we'll give you the project within 1 or 2 weeks. Okay. So fine then, guys. Thank you so much. Yes, you guys can leave. Okay. Thank you.